What we are looking at is one possible result of a process by which a group of students will learn, by discovery, what the properties of a polygon are. They'll learn more and have a deeper understanding than they would if told how to draw a polygon. In order to let the students feel the thrill of discovery, only the teacher should see this before they begin. The challenge is to get a sprite to draw a polygon with a specified number of sides without any knowledge of angles. The program being used is Scratch, which is one of the applications on the EXO computer. In Scratch, programs are drawn together by dragging in blocks from the various libraries and then building them into a program. In Scratch, variables are numbers, which represent numbers rather, which can be changed anywhere in the project, and the new value will be recognized wherever the variable is used. Sprites or subroutines communicate by sending and receiving broadcast messages, which can be recognized by one or all sprites. The project is based on a similar but more straightforward project which draws a circle. Sprite 5 is a simple version of this. It will work for only selected angles. Students can come back to investigate this more deeply after completing the Polygon challenge. Indeed, having done this exercise, they can come back to this to investigate any problem that they run into in geometry or trigonometry and figure out what is going on. Now we'll go to Sprite 5 and go to the circle. Now, before students generate this program, they should act out, in fact, they should act out each of the different variables in order to figure out how to program the sprites to do the same thing as they do. So this is the circle drawing program, which is fairly simple. There's some homework to be done, housework to be done to clear things up. And then they have this forever loop, which rather than keep going turn, move, turn, move, turn, move, this is one of the powerful ideas that they learn that is in the control library. There are these loops which will keep repeating either until they get a condition that they've set or forever, which is used in this case. Then, having figured out that what they want to do is to turn by a small degree, couple of degrees, and then move the number of steps, you can go around in a circle. But how do you tell when you've completed the circle? This can take quite a lot of discussion, but should be led to the idea that we start facing in a certain direction, which is displayed here as direction and can be read by the program. And when you get back to facing in the same direction, if you've done things right, you should have completed the circle. This doesn't always work, but that again will come on later on in the Polygon part of the program. So the idea is it's much easier if we start from heading in a direction 0 and end up in 0. And the advantage of that again will be shown when we get onto the actual polygon part of the thing. Now, when we're planning the polygon, we should separate different functions and have sprites performing the different functions, which makes it easier to understand what's happening and to follow and to make corrections, because it's easy to see where things are going wrong. There is an option when you go to the file thing here, so when you go to the edit, when you go to the edit menu, you can start single stepping. By single stepping, we can see exactly what is happening as the program progresses. Okay, so let's go to sprite 5, which is going to draw a circle, and we can start it by picking up here, and there it goes, it draws a circle. There are various things that have been added in here. One is the total number of degrees, which is 360. Drawn sides is not part of this, that's not being updated. Actually, neither is the single degree, then the total degrees. That comes later. So these numbers, most of these numbers come from the other program. Now, when we go to the Polygon challenge, we have, first of all, we have to initialize everything to get it started with a clean slate and with the variables set to a known value. Most of them set to 0, but not all. Then we want to do the drawing. So sprite 1 is setting the variables, and it's broadcasting here a draw, which is going out. And also to get the number of sides, it uses this ask block, which asks how many sides and waits until the user types a number in on the keyboard. Now, sprite number 2 is going to actually do the drawing. You'll see when the start flag is clicked, it cleans things up a bit. And then, when it receives the draw it thing, it sets the draw number sides to 0 because it wants to count those until it gets to the number that's being specified. And then it does basically the same thing as the circle. It's turning and moving. And it's incrementing the drawn sides. It's also incrementing the total degrees, which might not be in the first time round, but eventually, if the students are curious enough or prodded enough, they'll decide that it's a useful thing to know how many degrees you go through when you complete a closed figure. Okay, now there's an if loop set in here, and it says if drawn sides equal sides, okay. Then we'll stop drawing and we'll broadcast check it to, which goes to the next sprite. And you'll hide the sprite so you can see exactly what has been happening. And then the stop script, it's going to stop and wait until it receives draws again. Then the check it goes to sprite 3, which is when they've designated one that's going to check whether it's the end or not. And here we come to two powerful ideas. The first one is that we can get there by successive approximations, which means that we try one thing and then another, but we can control this by doing a binary search for the end. But we start by getting 5 kids to link arms and try to start with small angles and get bigger and bigger angles. We can get an idea of what we have to do in order to draw the polygon. And again, we start with a small angle, and then we're going to increment it. And here is where a useful number, or set of numbers, comes into play, because if we take 1, multiply it by 2, we get 2, we multiply that by 2, we get 4, we multiply that by 2, we get 8, we multiply that by 2, we get 16, then 32, and then 64. And these are useful numbers because we can keep dividing them by 2 and getting down to 1 without any fractional numbers. It's also the binary numbers that are used in computers, but that is completely by the way. Okay, so we start with small angle and it doesn't get back to 0, so we start with so we get a bigger number and a bigger number, and we keep incrementing by 16, which is chosen as the number to increment by. Then eventually we're either going to get to 0 or we're going to go past 0, depending on whether we've chosen a good number to start with or not. If we go past 0, this is where an interesting thing comes in. We'll now have to decide how are we going to tell that it's past 0 here, but it will be have an angle greater than 0 after the first step and so on. So we need to know what window we're going to be looking at here. And what we are looking for is that it's greater than 0. But if you think of how we get to where we are at that point, the maximum we can have gone past 0 is 1 angle. Because when we first started, we started at 0 and we went to 1 angle. We're starting from less than 0. We can't get quite to that point. It has to be less than that. So we say heading is 0, greater than 0, or it's less than angle. Then we know that we've just passed 0. And now we're going to a different mode, which we call finalize. And the reason we do that is that we're now going to start homing in on the number that we want to draw this polygon. So we set a flag that says finalize to 1. And also we set a flag that says negate, because we've gone too far, so we have to reduce the angle. Okay, and if the sides, drawn sides equal sides, then we send a broadcast a message of change angle, which is done by sprite 4. Now, what sprite 4 does is each time it takes off half of what it's been adding. So if it's adding 6 the first time, it changes that number to 8, and the second time to 4. Of course, the first time it has to be past it, the gate has to be 1, so you set the angle to angle minus change by. And we turn off the gate so it won't go backwards the next time. And otherwise, so we have if the gate equals 1, we subtract, else, which is otherwise, we add. And then we broadcast draw it, and sprite 2 goes back to drawing whatever the angles that have now been set will give it. So let's see what happens with this. It comes up with the question of how many sides, and I type in 5, and off it goes. And you can see it's getting closer and closer, but now it's gone too far, so it went back, it's gone too far, and it's still too far, and now it's stopped there. And this is where you can see that the total angles are 360, because that was one of the variables that we added. Total degrees of 360. And we've added this other thing. We say when we go from here to here, we turn to that angle. but there's another angle in here which is called the inside angle, which is there, which is used in geometry. And while we're going on this, we can do a thing, because this allows us to go to two sides, and then it will go round and round and keep trying and 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 trying, and it's got there. Now the angle is 180 degrees. So that if, when we looked at that polygon, if we'd gone from where we were going back to where we were coming from, which is the sum of the angle on the outside and the sum of the angle inside. If you think of it, we get that the inside angle is 180 degrees minus the angle that we can. So there are many ways of doing this, and hopefully each group will find a slightly different way of doing it, and that is also a useful lesson, that there's not a single way of solving a problem. There are many ways. Some of them are better than others. Some of them don't work at all. But if it doesn't work, you figure out why it doesn't work, and you use a single step, if you like, and then you fix it. And that is the way that in the real world we solve problems. So thank you very much for listening, and that is all that I have to say